So one of the things that I want to sort of prepare for everyone who's here today, if you're interested in being like interactive and following along, everything that you could need to do this is on my GitHub, which you cannot read that. Oh God, I'm so sorry. That color is awful. Wow. It's github.com/skirmer/animating_dataviz. If you want to clone the repo, you can have the data that I'll be using to do the visualization notebook that is actually the content of all these slides, and you can follow along yourself if you're so inclined. If you don't want to do it today, totally fine. You can do it at home at your leisure, and if you have questions or issues with that, just tweet at me, and that will be fine. So let's go back for just a moment before we do all that. So to give you a sense of sort of what to expect from this talk, so before we get into discussing how to do an animated visualization in R with gganimate, which is really, really fun and you will enjoy, we should talk about when is appropriate and when is not appropriate to do that thing. Aha, we've got a little bit of a bigger screen. That's good. So we should talk about like when to do this and when not to do this, because animation is not right for every problem. There are really, really hilarious ways to make a terrible data animation, just like any other data visualization option. So we're gonna talk about some of the pros and cons to doing this. And then we'll talk specifically about the packages that are involved. We'll walk through the code step by step. And specifically, I'm going to show you how to take a pretty basic data set where you could create a grouped bar plot, which I think a lot of people who use ggplot are pretty familiar with. You probably have to Google to remember position dodge and how that's going to work. But by and large, a grouped bar plot is pretty standard. We're going to convert it into a different kind of plot with animation. And so that's the process we're going to follow through here. If you can see the URL, you can also visit that and follow along on the slides on your own screen without having to look at all of the underlying gnarly code too. So, as I mentioned, this is the link. You can kind of see it now because the screen's a little bit bigger, so that's okay. But everyone's got your chance to take a look at that before we carry on. I wanted to also give you a little bit of an overview of me and how I ended up doing all this. I'm a data scientist. I work at a little startup called Journera, and I previously was at Uptake. And my roles in data science have involved a ton of visualization, partly because data science product is really not useful unless you can explain it to non-data scientists and explain why it's valuable for them to listen to you and what your results and what the analysis you've done can provide for them. And so visualization, I think, is one of the key tools in a data scientist's sort of toolbox, regardless of what language you're programming in or sort of what tools you choose to use. And so I think that this is an aspect of data science that's maybe a little it can be a little underappreciated, but really getting that last mile to making your analysis actually, productionalized or useful or generating change in your business or your organization really requires some proficiency with the visualization stuff too. So, oops, clicked the wrong one. So, animation in data visualization terms, you find out I can just animate these plots that I've been making in R. Let's animate all the plots. No, don't do that. Don't do that. Animate some of the plots and then leave some of the plots as static plots because they are gorgeous and perfect just the way they are. It's neat, yes. And learning how to do it because it's neat, totally correct. Giving your boss an animated plot because it's neat, not necessarily the right thing to do. Also, you have learned how to do this and now you want to show off and you want to show everyone else that you can do that. That's not good either. Also, an interesting point that sometimes comes up when people are thinking about doing an animation is that they think because a dimension in their data set is time, that they need to use time in the context of the visualization to show that. So if there's multiple years of data, well, I have to use a visualization to show multiple years of data that are occurring over time. That's not appropriate. That's confusing the content with the sort of method. And sometimes, as in fact, in the case of the example I'm going to show today, time is relevant and is part of this, but only because we're displaying, as it talks about under the good reasons, 4 or more meaningful data dimensions. if you have data where, say, using a faceting plot where it shows a subplot for each level of a dimension, still can't cover all of the dimensions of your data, then you should start thinking about an animation. And I'll explain a little bit more about that later on. But similarly, if within your data, your single feature of your data, there are many, many levels of a single dimension. Like you don't have 3 years of data, you have 30 years of data. You want to show each individual, you can't show 30 little teeny tiny plots on the screen. That's just not going to be effective. So if you have many dimensions of data, or you have very diverse levels within a single dimension, then animation might be appropriate. Also consider that as an animation, by nature of it, by definition, all of the data points will not be available on the screen to the viewer at the same time. They might be shadowed, they might be grayed out, something like that, but they won't be all together, all in the same context at the same time. So think about that. Is it really necessary that you see all the data all together at once to draw the conclusions you want to draw? If so, probably not an animation problem. So there's a few use case ideas, and I want to talk a little bit about the different ways and possibilities for using animation effectively. So Thomas Len Peterson is the author of gganimate. He has written a ton of amazing packages for data visualization in R. And this is his use case that he sort of has on the instrumental sort of instructions for gganimate and how it works. And so this is looking at continents. You can't really see the text, unfortunately. I do apologize for that. But they're continents, and they're showing on your your x-axis GDP, and on your y-axis is life expectancy. So it's economic against health outcomes, basically. And you're seeing some interesting stuff here. You're seeing data in meaningful groups. GDP and life expectancy makes sense. That's a useful thing. You're seeing it across more than 3 dimensions, right? You're seeing 4 dimensions. You're seeing year, continent, GDP, and life expectancy. You can't really display that effectively on one single plot without overwhelming your user. But this plot is not showing you some things. So if I was to try and really quantify the trends that we're seeing for each of these continents in comparison to each other, that's a little hard because they're located across the facets, and it's a little bit complicated to see. You don't see all the points for each continent at the same time. They're moving as the years go by. So you don't really see the beginning, the first year, along with the last year. It's comparing across continents, as I said, is a little complicated because of the facets and the way he's decided to do that, which is a decision choice for design. And then considering the way that this is designed, you can back out what does the viewer or does the designer really want you to know, and what is it not so important that they think you take away from this. And I'll talk about that a little bit more when I talk about the project example that I'm going to show you today. There are many more awesome examples. Oops, I didn't click both ways. And I just grabbed some of my favorites that were really a little off the beaten path and a little bit interesting, not just the same old year after year after year the data moves along, which is, again, I am going to do one of those plots for you today, so I can't snipe at that too much, but there are lots of other ways you can do this. You can use a plot to show the change in forecasted range of values over time, the way that is done by Hauye on the forecasting one. You can show the reveal of groups over time, which is a really interesting approach. Obviously, geographic data lends itself really well to this kind of thing because movement of some sort of information across a geographic plane creates a really interesting visual that is very accessible to a lot of viewers. So you can see Daniela Vasquez did one of those. So I highly recommend that you take a look at these if you're thinking, my data is too big to show in one single plot. It's too much, it's too heavy, it's too overbearing, but I don't really know how I would animate this. These are some really good examples that I recommend you take a look at later on. So let's think about the design of your visualization. As I've been talking about, the information you want the audience to take away is kind of the key cornerstone of where you're going. You need to be designing a visualization for a purpose, not just because it's cool. And as we've discussed, it is cool, and that is a great reason to learn how to do this and do it in your own time. But thinking about an audience and thinking about sharing something with a group of other people, what do you want them to learn from this? This is transmitting information through data, otherwise it would just be art. And so movement, using animation has insinuations, and it creates learning on the part of the viewer, whether you mean it to or not. And so movement leads the viewer to thinking about these data points in a relationship with each other. If data points move and it looks like it's the same point moving across the plot, you think that's the same unit. It's the same thing moving across. If points on the plot are the same color and they move together or move apart or something like that, it's creating a space where people will draw conclusions, and you need to preemptively think about what conclusions they might draw from it. The speed you choose for your animation is super important. If things move very slowly or things move very fast, regardless of whether the space in between the points or the space in between your frames really is like a speed-based thing, people will watch it and they will think, oh, it's moving fast, so that means X, Y, Z. So use, an uninformed audience of, friends or family, and put the plot in front of them and ask what kind of intuitions they take away, what kind of things they assume about what your data is based on the animations that you've chosen. And I also feel very strongly that each static frame, which we'll talk about a little bit about what frames are and what that really means, but each single static snapshot of your visualization should be informative alone. It doesn't have to tell the whole story. You can be using this animation to tell a longer sort of narrative, but each static frame should say something useful. If there's a static frame that has like a 1 point and it has no other frame information around it, I'm not totally a fan of that approach. This is a philosophy that I'm personally very opinionated about, but this is, buyer beware as well. And once again, as I've said, animation is rad, it's really fun, it's gonna be awesome, we're gonna have a great time, but it doesn't necessarily fit every problem. Okay, so talking about the packages, talking about what we are working with and the sort of language that we need to be familiar with as we're going along. So the packages that are absolutely necessary are ggplot, gganimate, and gifski. I think is pretty important if you want to render GIFs and save them to your computer. That's not absolutely mandatory, but I strongly recommend it. And then there are some other packages that are useful, optional packages that might be interesting. Transformer helps to create additional options for the transformation, smoothness, and that kind of thing. Patchwork is another Thomas Lynn Peterson package that allows you to arrange multiple plots in a single layout, which can be really neat. And then ggforce extends ggplot functionality some, and it's handy for certain labeling needs and things like that. So now we have a few phrases and words that we need to be aware of as we're going along. These are going to be words that will help you make sense of the sort of lexicon of animating your visualization if this is something you don't have any previous familiarity with. So a frame is just a single image that is combined in a series, strung together to make an animation. So we really are like the old-timey cartoons, doing one little cell at a time, and we're going to string them all together like a flip book, and then they're going to make an animation. That's really how this works. So you think about the frame as not a unit of time, but as a unit of visual space. And you can cram as many frames into each unit of time as you like. So frames per second is a sort of thing that we understand. If each frame is different and you cram a lot into frames per second, your animation looks really fast. And if you have many frames with a lot of information, but you spread them out over time, it will look very slow. State is a different thing, and this is very important to keep track of. A state is the grouping variable being shown. So if you're looking at a visualization that has one frame or has a year in a single frame, or is a single state, then that every time it shows 1998, 1999, 2000, and so on, then that's the state. The state is what year you're showing right now. Your state can extend beyond one frame. You can hold on 1998 for 1, 2, 3, 4 frames, however many frames per second that is. and then move to 1999, 2000, 2001 in one frame each. You can change up how many things are in each frame and then in each unit of time and how that all works. I know this may sound super confusing. I do apologize. We will do it in real life and you'll get to see real examples of changing the speed and things like that, and you'll get to see how it looks. So now transition is how you move from state to state. So you can just, 1998 disappears off the map and 1999 appears. That's one option. That's a transition option. But you could also have 1998 fades out and 1999 fades in. Or you can have 1998 bounces off the screen to one side and 1999 bounces in from the other side. I swear this is a thing you can actually do with gganimate. It's great. But transitioning is how you move between states that exist. And now those are for points or for elements of your data that continue between states. Entering and exiting is when a data point with absolutely no predecessor or follower is either brought in or leaves the plot. So if 1999 is the last year you have data for, Texas, say, if you're using a data set with states in it, then the way that Texas disappears from your plot is the exit for that rather than a transition into a next state. So I hope that this is somewhat clear. We'll go over it in real examples in just a sec here. Okay. So now we're going to actually get into code, and we're actually going to look at how we go from bar plot to animated plot, and so I will get right into it. So the project that I'm going to use as my example here, absolutely for no reason at all other than that this is a data set that I found on data.world and it looked interesting and it's UN data, so it's public source and you can use it any way you want. And you can follow along if you're so inclined, is a data set on refugees and displaced persons living in South Africa over the course of many years and the locations that they are originating from specifically. Okay, absolutely no reason to pick this data other than it was a useful example and it would work for this. So the questions that we're going to be able to use our animation to ask or answer are, where do these refugees come from? Where do most of them come from? What places are high political or social instability occurring so that people are entering South Africa from these other places? And then, are these most common countries of origin staying the same? Are they changing? What is the pattern amongst the most common countries? And generally, is the number of refugees coming from these countries stable? These are the questions that I want to be able to answer with the visualization that I'm doing in this project. So let's look at our data. We've pulled up the data set, which is again available on GitHub if you're so inclined, you want to look at it. Just threw it in here, and the code to actually load the data is in the notebook on GitHub, so you can also do that. We've got the year. We've got the country of residence, South Africa, because they're all in South Africa, because that's the whole point of this. A country of origin is, there are many countries of origin, and population type. So we have refugees, we have returned refugees, we have displaced persons. There are a few other groups. And then we just have the number affected. So I didn't have to summarize this data myself already. You could very easily do this with a little bit of dplyr and group and summarize. So you can get to this point with any data that you have individual records for without a whole lot of fuss. So I'm not going to go through those steps because I assume that you can Google for yourself how to do that bit. But so we want to mutate this data a little bit because it's not quite in the format where we want it. First off, country various unknown is not especially useful. I don't really need to put those in my plot simply because it doesn't tell the viewer anything when I say various countries. What is that information communicating to the viewer? Not a lot, so I'm going to omit those candidates. I'm going to only include refugees, including refugee-like situations, because I'm going to narrow this down to a single subgroup of individuals because that's what I want to communicate. That's the information I want to transmit to my audience. Then I'm going to rank my countries. And this is a little snippet of code that's really actually very neat. It just takes the number, puts the rank in there, and then it doesn't double up on rankings if they're overlapping or if they match up. That's really all it does. So then I'm grouping, and then I'm going to take only the top 10 by rank, and that's it. And so that gets us this. It didn't change a whole lot, as you could see. We still got year, still got country of residence, country of origin, so on. Now we have only the certain subgroup of population that we're looking for, and now we have a ranking field on the side. This is very important. It will come in handy later for the kind of plot that we're doing. So now we're going to do a group bar plot. Nothing fancy. It's a very short bit of code. It's just a ggplot call here. Our group is country of origin, so we're going to have the country on the side. And we've only got those top 10 countries for each year reminded. So we have a relatively small number of countries total, although it's still going to look pretty gnarly, as you'll see in a minute. Putting our legend on the plot, making sure that the color is the country of origin, and a few little aesthetic details here. But basically, a very standard group bar plot where position dodge I have remembered how to do. Hooray. Anyone who uses R a lot remembers that that's really complicated. So here's our countries. We've got a legend that tells us the names of the countries, which is nice. And because we certainly don't want them on the plot because there are a lot of them and there are a lot of years. And this is an ugly plot. Ugh. So if my data was small enough and manageable enough to do this, then I would use a group bar plot and that might be the end of my problems. This is not the end of my problems, oh no. So what I'm going to produce instead is this. And I'm going to show you how to generate that from the code that we just wrote with the standard grouped bar plot. So as you can see, it's moving along. It's kind of trendy. These little race plots are very fun right now. Lots of people are generating them. You can do your own in 5 minutes using gganimate though, and that's what I think is really neat. You don't need to know D3, although D3 is great. You can just do this. Okay. So the first thing we need to do is flip our axis. So this is really not too fancy, honestly. We're just flipping the axis and we're giving it a little bit of extra space so that instead of having vertical bars, we're going to go to horizontal, because that's, I think, obviously the first thing we notice is different about these two plots. We're going to give the y-axis a little bit of extra space, and now we have a horizontal plot. It's not better. Oops. That's okay. This is just a stopping off point on our way to visual awesomeness, so don't worry about that. So then there are a few other things we need to do. We need to stop bar grouping, and we need to switch the axis to country from year. Because what we want is those horizontal bars to represent the country. We don't want them to represent the year, because the year is going to be our state. So we're going to take the aesthetic frame. We can't use the same stub, unfortunately. We can't just keep adding to our ggplot, which is obviously the most, the easiest way to go about these things a lot of times. Instead, we need to go back to the original aesthetic and we need to change a few things. So now our x variable is rank. So the x is going to actually be on the y because we've switched our axes, remember, and it's going to give the rank as the ordering of the bars along our faux y-axis. Grouping by country, filling is country, color is country, that's all pretty much the same. And then we're adding our bar at the bottom is now position identity, not position dodge, because we want them to just all be laid out on the same way. And so now we've got something like this, but you'll notice we can't see all the data all at once because it's all flattened right on top of each other, which is okay. We're going to deal with this in a minute, but this is kind of where we've come, right? So we started with horizontal garbage, and now we have slightly less garbage. Maybe, we've added a few different details to it, and we need to make a few more improvements yet. Let me go back one and make sure that yes, and that's another thing to keep in mind is that we have added the names of the countries to the axis there. Okay, so we're back. Now, margins, axis text, moving that legend out of the way because we don't need that legend anymore. There's just some tidying up bits that we have to do, but we can just add these onto the existing plot. We don't need to start a new stub. Our stub is solid. We can just start adding new things. Thematic elements are really really important to getting an animation and a visualization the way you want them. And conveniently, we can just overwrite the existing theme this way. So we don't want a legend, we're getting rid of that. We don't want axis ticks, we don't want text on the y-axis. We want to just clean up all this stuff, get rid of a bunch of kind of garbagey stuff that we had. And because we have so much text on that faux y-axis, because the country names are so long, we need to give it a lot more space. And so that's what we're going to do with this next bit. So now, hey, there's a little more space there. We can see the overlay a country name. It's a work in progress. We're getting there. Okay. And we've got a nice clean y-axis. It's going to get cleaner yet, but we're not seeing a whole bunch of excess sort of plot garbage that would have otherwise been in the way. So now, prettifying the y-axis, if you aren't familiar with this, this is one of a secret little lovely thing that you can do with scale y continuous, or actually I think scale x continuous as well, is you can add a comma to the thousands marker. It's just nice. You don't have to go in and change your original data. You don't have to convert it to character. You don't have to do any of that nonsense. You just add scales equals comma, and then it will be there. And then we're also going to flip the x so that the ranking goes from 1 to 10 instead of 10 to 1. So, ta-da. Look at those little commas. Isn't that great? I just thought that was really cool. I don't know, because you get to looking at these plots and like the zeros start to all blend together and you're like, what is even this number? Or you start getting into like, exponential values. You're like, oh God. And then, scientific notation is not what you want on an axis. So this is nice. So we have all the frames all layered on top of each other, or the states, as you might put it. And so we want to then figure out how to go on and proceed to the next step. Let's remember our goals. Where do the refugees come from? What are the most common countries of origin? Are they usually about the same? And is the total number staying stable, or is it dramatically changing over time? So before we go animating, before we get too crazy, let's just check, would faceting be a viable option with these plots? I'm sorry, I didn't want to show you this, but I just had to, just to prove that this is really a good case for an animation. Yeah. Oh dear. Yes, no, okay, I'll move this off the screen as fast as possible because those are very bad. But just so you know, those are the options that you have still to review whether a facet of either facet grid or facet wrap would be a viable option. If you really need to show this data, every point and every frame needs to be on the screen at the same time, those are the things you need to try and do. Or you need to lower the dimensionality of your data some way so that you don't have to go through all that trouble. Okay. So this is going to sound really crazy, but you just have to add one line to turn that into an animation. Transition states X date year means that now the state identifier is the year. And then we get this. We're not done. It still has icky elements, but it's doing the thing that we basically wanted to do. It's moving the plots around. It's really moving from state to state to state to state. And so all of those states that we had all flattened on top of each other are now being shown sequentially. And so that's it. So let's make it better though, of course. We can't tell what the frames represent or the states are at this point. We don't know that it's years. It could be anything, really. The x-axis, or the y-axis, sorry, it needs some labels. We don't really know what the length of the bars means. It could be, any number of things. And the movement, as you can see, is really kind of janky. It's a little bit like jolting. It's moving really harshly through the plot. And so we're going to fix all of those things and make sure that we have a plot that's really nice. So the dynamic labels, that's one of the things that gganimate provides as an option. Is this late? Oh. It is kind of giving me a mouse cursor. Oh, well, whatever. So gganimate allows us to add titles that have variables in them. As you can see here, the little curly brace says closest state, which means whatever the year that it's closest to in the plot, in life of your animation, in the timeline, will just be generated into the title. So we have refugees residing in South Africa by origin, year. And then affected persons for the y-axis, just so that we know what we're referring to here. And then the label can just be the X affected, and it doesn't actually have to have anything to do with gganimate, because remember, these are the little frames are just laid in on top of each other. So the frame will have that label, and it will just move itself into space when the frame shows up, or when the state shows up. So now we have this. So you can see our title is now changing as the animation changes so that we know what the hell it is we're looking at, and that's great. And we have nice little labels on all of the bars so that we can see what these are actually meant to represent. So we're really getting to like showing people something that actually might be valuable, useful information. It's great. So then we've solved the problems of do we know what we're looking at and what do these things mean? And that's all great. But the transitioning thing is actually very important. The jagged kind of movement is still harsh and still a little obnoxious to watch. So I'm going to spend a little bit of time talking about just some of your choices when it comes to changing the transitions and the exit and entry kind of animation elements here. This stuff can be a little bit complicated because what you're working with is figuring out how you want gganimate to move between the frames and understanding the stuff about how the exits and entries work and how the sort of space and time operate together can be a little complicated. So we'll walk through it with some clarity, hopefully. So one of your choices is shrink and grow, as I think I mentioned earlier, is you can add these after transition states, and we'll talk a little bit in detail in a few minutes about what transition states really means. You can add enter, grow, exit, shrink. And that's it. That's all you really need to do to get something like this. It's a little cartoony. It's a little like kind of weird. For some project objectives, for some animations, for some case studies, use cases, this could be really useful. I don't think it's quite what we need for this. You might disagree. You might think this is the best. And that's totally a personal opinion question. So let's go for another option, easing. Easing is between positions moving on the page. We have options for adding a function for the easing. So ease AES allows us to add cubic or quartic or other things. There are other options actually that I haven't really looked too much into. But so this will mean that the ease changes in speed as it goes. And it's a little bit subtle, but maybe you can see that it sort of starts slow and then goes faster, slow and then goes faster. And it's kind of cool. It has some interesting options. And for, once again, the right use case, for the right situation, this is an option that could be kind of neat. Testing these, playing around with them, and seeing what looks right with your data and seeing what your family or friends, when viewing the visualization, find aesthetically pleasing and find that it doesn't insinuate information that you don't want them to think. That's really how you choose, in my opinion, between these. So then we have other more energetic options. This one is just straight up fun and ridiculous, honestly, if you ask me. But this one is called back in and out. And so it kind of bounces. It has energy to it. Bounce is actually an option as well. It's a sort of separate one. But you'll see when things move, they kind of move a little too far and then bounce back. And if it's a thing you're interested in, it's available. I just wanted to make sure that you were aware of that. It's kind of neat because you go wing and it bounces around. It's like little elastic bands have been attached to your frames. And yeah, it's an option. It's a little cartoony, not right for the serious, important information that I'm trying to represent to an audience here, but it's there for you in the future. So then, timing is a separate question beyond the easing choices. So we talked about you can add a function to the easing in and out so that it moves at changes of speed within the transition, but you also need to think about how long each frame should stay on the screen or how long each state should stay on the screen. In this case, we're looking specifically at state length, and I want to talk a little bit about how that all works in this case. When inside the transition states argument to your ggplot, you can add the transition length, which is how many frames your transition should take, and your state length, which is how many frames your state should take. This is not in minutes and seconds, this is in frames. So think about that. Transition length, in this case, I want it to be 5. I want the transition to be long, and I want the state to be short, so that it doesn't stay in one place and then jump really fast, but that it gets to one place, holds for just a second, and then smoothly moves into the next place. And so I want smoothness, longer transitions, shorter states, okay? Then I've also, if you can see here, let me see if I can do this without making the microphone die. At the end of state length, I'm repeating 0.25 over and over, so it's a quarter of a frame, quarter of a frame, quarter of a frame. 20 is the last one. I want 20 frames for the last one. That is the last frame, or last state in the group. So I've got a total of 22 states. I want the last one to hold, because it's the very end, and I want to make sure that the viewer has a chance to sort of digest, see what they've been working with, see what the information has led them to, and then have a little moment to breathe before it starts over again. Also, wrap false means that the transitions that I've been doing, the flow in and out and all that, will not happen between the last frame and starting over. So the last frame gives them a second to breathe, stop, and then it jolts into back to the beginning. So it's very clear, this is not continuation of the series, this is starting over from the beginning. As for everything else, it's exactly the same as the stuff that we've been looking at before, and it hasn't changed at all. So this is what we get now. So as you can see, the transition move is long, and the staying in one place, which you can really kind of measure visually by looking at the number. The time that the number stays in one place is pretty short. And that's the thing that I'm trying to create. You can also look at the date or the year and see how long that takes. But I think that the number shifts when the frame starts to, or the state starts to shift, and that's the way that you can kind of see how the time is moving. But so this is what I ended up on, and I was pretty happy with it. I feel like with these racing plots, one of the points is that they're continuous as much as one can be. They're racing and not like getting to a point and stopping, and then getting to a point and stopping. But I felt like the smoothness worked for this. But it is very much a design opinion, perspective kind of question, and it's the sort of thing that you can experiment with and try different things. So we're gonna do a little more. I wanna talk about the transition states section just a little bit more so that you're very clear on exactly what you're getting when you're editing this section. Because I messed around with this and got really into the weeds and got a lot of weird stuff. So let's see, there's things, I actually mostly mentioned some of this stuff already. So just to remember, the transition length is how long you're giving it to change from state to state in frames. And then state length is how long you're giving it to sit static in frames. We'll talk a little bit about the frames per second thing in a second when we export the plot to a GIF, because that's where you get to set the frames per state yourself, or you can do it when you're animating. Okay. So here we go. So now this animate call is taking the ggplot that I have generated previously and then actually generating the animation. FPS, frames per second. So I'm at 10 frames per second in this case. Remember, the more frames you cram into a second, the faster it is. So if you wanted to do 20 frames per second, it would be a rockin' fast. If you do 5 frames per second, it's gonna slow down. And that's just, a good rule of thumb to remember when you're trying to figure this out. Duration total, I have 20 seconds set. So that then creates a sense of how long I want the whole thing to keep going. Wait, I might be wrong about what duration is, actually. Don't quote me on that. Look that one up before you decide to use it. But the width and height are just exporting tools for when you're actually generating the animation for either screen presentation or for someplace else. The sizing of plots will then have an effect on the font size that you get. And so keep that in mind. If you need it to be very easy to see, you might need to go back and think about the font sizes you've chosen in your ggplot. And then you can save it in this. So anim save, give it a file name, send it on its way. It's the last animation that you rendered, so it will know that you've animated this plot, and it's almost a Pythonic kind of thing where it's like you generate the plot and it knows it's there, and it's not going to get confused about what you're trying to tell it to save out. It's not a very actually R sort of languagey kind of thing. It doesn't ask for you to call the animation. But you've got it. That's the animation. You've created a racing plot, and you can do that with any data of your own. Going back to sort of the beginning, this is very cool and it's very fun, but is not right for every problem. As we've established, I think you've gotten that lesson from this. So make sure you're thinking about prioritizing your transmission of information. A data visualization is meant to help someone else can get information more effectively than they would have otherwise. And if you generate a graph or a visualization that's too busy or doesn't show the right information at the right time or doesn't give the viewer what they need to understand the communication you're trying to produce, then you're not doing your audience the service that they need. Also, once you've decided you need animation, make it awesome. use speed, use transitions, make it bounce if you want to, if you think that's going to help. Really give some attention to these little tweaky things that might seem, like kind of nice to have. I really think that these are important to making sure that the audience understands what you want them to understand out of it. The speed and the way that things move, making sure that they have enough time to see each state and understand what each frame is before it moves on. That's really important. Test your animations on friends, family, Twitter, whoever, and make sure that people are understanding what you meant them to get out of it, and then tweak accordingly and make it work. And more links. There's so many more links. There's so many really cool animations that are being done with gganimate. Of course, also with D3. There's another racing plot that I found that was just happened to be done in D3 and it has really good code available. So if you're interested in not doing this in ARM but doing it some other way, please, by all means, go mess around. There are some just really awesome options out there and ways that you can do this yourself, and then you can show off your visualizations with animation online as well. And then you can be links to the next time I do this. Yeah, please let me know if you have questions. I will be around. I think we can probably do questions as an audience here. And follow me on Twitter. Tweet at me if you have questions. That's the best way to get a hold of me if you have questions later on. Thank you. Oh no. Well, they can have this one then if you want. I don't know.
Can you hear this one?
No, I can't hear it. Here, this one. I just turned it back on.
Cool. I'm going to run around for questions. We'll do like 10 minutes of questions. So if anyone has one, just raise your hand and I'll bring you the mic.
I'll be real loud when I answer, I promise.
Thank you. That was a very beautiful talk, first of all. Yeah. So when you were saying easing out, right, what was the thing about the state being getting shorter? How did you?
Oh yeah. Okay. So when you're deciding how long the state should be versus how long the transition should be, the state, remember, is the static point where the data isn't changing. For how long do you want the data to not change? And if you're showing very complicated information or complicated details, like very small points or something like that, I recommend keeping your state a little longer. It might create a little bit more of a jumpy feel, but if it moves away too fast, they're not going to be able to get it through the eyeballs to the brain, understand it, and then be able to be prepared for the next thing. And so I think that's what I would say about choosing the length of the state. Because remember, we're doing seconds to frames to states. So the state can be as many frames as you want, and you can have as many frames per second as you want. So you need to I did a lot of actual little mathematical things on the back of a notepad as I was doing these, because I'm trying to think, okay, if I get it to that point, and I want it to be this long, how many frames and how many states do I need, and that kind of thing. Yeah. I hope that helps. There's another question here.
So, did you have any or follow any thumb rules while implementing this project, and as well as are there any generic thumb rules while doing gganimate?
Thumb rules? Other than the ones that I explained in there about thinking about what you're doing before you do it, I think I probably put most of what I was thinking in there. I think one thing that I didn't do, which it was probably a thing that you should consider, especially if you're doing a visualization for a in a business setting, is color. Think about the color you're using. I just used the colors that it gave me because they were kind of bright and fun, and I thought, okay, that's fine. But don't necessarily take the default colors. ggplot has 1,000,001 color schemes that you can choose from, and they're pre-built, and it's very easy. So I would say consider that as well. But yeah, the effective visualization is the goal. If animation can get you there, use animation. If something else is going to get you there, use that instead. And, animate things for yourself for fun in your spare time, and that's different. So.
If you want to hone in on a specific year that had a significant impact, what would you recommend to show that? Can you pause it or?
Yes. Well, so what I would do, actually I'm still mic'd. I can't walk too far, sorry. So what I would do with that is, remember when, I guess, can I go back? I'll go back, hold on. I'll show you where you can change that. Okay. Okay, so here where I have state length here, see repeating 0.25 for 21. So I'm saying 21 of these states will be 0.25 frames each. You can change that. You can have that vector of the state length can be any vector you want. So you can say, I want 2005 to be paused on for 4 frames. And you can just have a 4 in there instead. And so that's what I'm doing here with the very last frame, is saying 20 so that it stops, breathes for a few seconds, and then moves on. So that's where I would say you get to really change when and how the frames keep going again. And that is separate from choosing your frames per second and all of that. Does that help? Okay. We've got one up here in the front, one there. Okay, Jeff, 1 and 2, yes. All right, whichever way. Hi.
In the same vein, I was wondering if there's a way to have an option to kind of like click through, or if it stops at the end and click to restart.
So you can have it not start again at the end and have it like be a refresh to restart. I am not certain that there's a way, because if you're doing click through, it's no longer really an animation, right? It's
the same transitions.
Yeah, I don't know. I'm not familiar with a way that you can make it a manual transition rather than automated. It's probably a thing you can do out there somewhere. It might not be a gganimate thing, it might be something else. But you can also, when you save this out, you're saving it as a GIF, you have all the individual frames in the GIF. And so you could take those, cut them apart, do something kind of fancy and wild with those if you're so inclined. Yeah, the only ones that I have experience with are moving on their own accord, and they're not like interactive. And this sort of thing, you can render it in like the plot window in our studio, or you can export it in a number of different graphical formats, but I don't think there's one that is like HTML kind of based. I think maybe a Shiny app might be a good way to go about that though, because then you could have the series of data in there and then obviously be more interactive, might be an option. It's an interesting question.
Thank you.
Yes.
So I was wondering if it's possible to stack different animations together using gganimate. So say like the first animation is the Americas, and then it immediately transitions to like Europe.
Oh yeah, definitely. That's just a matter of shaping your underlying data. So you need to like melt it down so that instead of like, so that one of your columns is continent, and you can also have the title bar say continent and year. So you would have like all of the years and all of Africa, and then right in the next, like the same column, keep going down all of the years in America and so on and so forth. It's the same thing really as the countries here, right? So I could have just all of Somalia goes one, and then all of Congo goes next, and so on. Instead of having them all in the same plot together, you could just have them all in one long row, and then it's going to go through and use each row of your data as a frame if that's the way you plot your static plot. So you make your plot that is all the states all collapsed on top of each other, and then it will just do the same thing. It'll just keep going until you tell it to stop. Hey.
Hey. So when you think about forms of presenting your story, animated plots are not always available. Mm-hmm. So what would you do to reduce the dimensionality of this when you're telling a story like in a printed version, for instance?
That's a good question. Okay, so one of the like terrible approaches to this that I showed earlier, where's the really bad ones? Hold on, let's go back. Okay, so like one of these. So this is showing all the years in a single facet, and it's ugly as sin. It's really not good, right? So you could decide to show a limited number of years. You could go every 5 years, every 3 years, and only show those. You also, in this case, I'm using the rank to cut down the number of countries. You could cut further on the number of countries and only the top 3. That would reduce the dimensionality. That would make it a little easier here. You could also group countries if they're similar enough, or regions or something like that, and use those as one of your grouping variables instead, and that could be useful. Let's see, what else could you do? Yeah, I think that those are some of the options that come to mind. I already did reduce the dimensionality some by choosing only the refugees and not the displaced persons and every all the other groups that were in there. So yeah, I think thinking about how can you group, can you communicate the information you want to communicate while only including certain categories or certain groups, things like that? Or maybe you just need multiple plots and you just have a series of plots and use Markdown and just scroll through the plots. It's not the worst thing in the world, and that might be useful too.
We have time for one or two more?
So when you embed this in a Shiny app, does it render at the same speed when there are a large number of concurrent users using the app?
I have no idea. It's just a GIF though, so what you could do is render the GIF and save it out, and then you just call the image in your Shiny app, and theoretically it should load the image when you load the app, and it should just play. It might make your initial load time of the Shiny app a little longer, but then again, depending on your backend, that might be the least of your worries with the Shiny app because those backends can be kind of clunky. But that's what I would say. Don't use the NM. Let's go. Oh, going the wrong way. Okay, so the initial call to NM allows you to. Let's go here. Come on. So far. Yeah, one too many. So the animate call here. If you render it this way, it's going to have to load in every time, and that could be really slow. So I would go, no, this way to this one. Save the GIF. Have that be on the in memory so that then it's not reloading every time it needs to run and that kind of thing.
Yeah. So for example, users want to upload their own data and you write this inside a function and call the function.
Oh my, that sounds like an interesting project, but yes, it will take time. I don't know how much necessarily. Also, you would really have to be pretty sure about the dimensions of that customer data, right, or that user data, to know if the animation code you have written will work and will show their data in a way that's appropriate. You could also, of course, let the customer set some of the details about the animation that's going to render, but at a certain point, they should just be writing their animation code, maybe? I don't know. Maybe I'm expecting too much from users, but yeah, it's gonna definitely take some time to render. The one that I've got here, I mean, when I got it to a larger size, especially if you increase the overall time that it's gonna take, it can take a few seconds to actually save the GIF and to render the plot. This is all cached for a reason. I don't let it render fresh every time because then we would all just be sitting here, playing Jeopardy music while we wait. Yeah.
All right, cool. Thank you so much.
Thank you.